Hey guys, Mr. Holly. I know that you're working on all of your worksheets, some of you at home, some of you in class, and some of us, we just haven't had a chance to have enough in-class instruction. So as I'm looking at some of your practice, I just wanted to make sure that you have the support that you need. So I'd actually like to go through some of this practice with you and just really reinforce the steps to solve equations and make sure that you're doing it correctly, make sure that you're going through the procedures, because our goal is to really learn how to solve these equations, not just look for answers, not just rationalize or solve with intuition, but to really work through them. So I'll start with the easier ones and then we'll work our way through. So when we look at like question number 1, for instance, m plus 12 is equal to 10. What we're saying here, and we've had this discussion in class, this equal sign means that both of these sides are equivalent. We're talking about two equivalent values. Some value m plus 12 is equal to 10. So my goal is to isolate this variable, to get it by itself. Currently, it has a value of 12 being added to it. I would like nothing to be added to 12. I would like it to be by itself. So in order for me to get that by itself, I can subtract 12. And again, this goes back to what we've been working on all year, creating zero, additive inverse. I'm going to do the opposite of addition, the inverse operation here. I'm going to subtract 12. That's going to create a zero pair. Now, with an equation, in order to keep this side equivalent, if we both start with the same amount and I take away 12 from my amount, then you would need to take away 12 from your amount and we would still be even wherever we start. So in this equation, I'm taking away 12 from the left side of the equation. If I take away 12 from the right side of the equation, whatever the values are, they'll continue to be even because I've changed them both by the same amount. So this creates a zero pair, plus 12 minus 12. I get m is equal to 10 minus 12, which is negative 2. And then we could go back and check that. Is negative 2 plus 12 equal to 10? Yeah, it is. So that works. Let's come down here to like the two-step equations. Now when I've got two steps, not only do I have some number being added to the x variable, which we call this number a constant, I have some constant being added, but I also have a coefficient of x, meaning x is being coefficient, which means x is being multiplied by something. So our strategy with this is that we are going to use your order of operations, PEMDAS. We're actually going to use that acronym, but we're going to work backwards. In other words, I want to undo this addition and subtraction first, or I want to undo the multiplication and division. I need to do the opposite. Just like up here, we were adding 12, so we subtracted 12 to get to 0. Well, here I've got addition and multiplication. I've got to undo those or do the inverse operations, the additive inverse, the multiplicative inverse, so that I can get x by itself. We call that isolating the variable. Now, if I'm looking at order of operations, addition and subtraction would be the last thing that I would do, but when I'm solving, they're the first thing that I undo or that I do the inverse of. So here I have addition. I would like to subtract 8. I would like to get rid of this to create a zero pair to add the inverse. Let's say it a few different ways. And if I do that on the left side, I must do that on the right side. I have to do the same thing to each side of the equation to keep it balanced or equivalent. This is now 0, so now I have 6x plus nothing is equal to 42. Because I've subtracted 8 over here. Now, I don't want to know the value of 6 x's. I want to know the value of 1 x. Right now that x is being multiplied by 6. I want to divide or do the inverse of multiplying, or we could even say multiply by the inverse. We could multiply by 1/6. I want to do the inverse of multiplying x by 6, which would be dividing by 6. And you can clearly see that if I have 6 times x and I divide by 6, these create a factor of 1, which means I would have 1x. And that's going to be equal to 7. Does this work? Well, look at our original equation. 6 times 7 is 42, plus 8 is equal to 50. Yes, 7 is the value of x that makes this equation true. I've already done a video on how to distribute if you have parentheses. Let's look at these rational expressions on the back. Let's do one of those as another support. With a rational expression like this, I have x plus 11 divided by 8 is equal to negative 3. Now, when I look at this, I have to think about, remember we talked about, we do PEMDAS in reverse, right? Like we are working backwards. And your first instinct might be to say, hey, I see addition here. But as you grow in your math skills, what you're going to realize is that parentheses are not the only way to group numbers. And you may actually encounter some groupings that are implied. This is an example, and this is why it says watch out, of hidden parentheses. They're not really parentheses, but numbers are grouped together. I want to show you how this is a group. Because this is x plus 11 divided by 8, I want you to see that that's the same as, and we're not going to solve it like this, but that is the same as x plus 11 divided by 8, right? How would I would have to have parentheses here to show that I'm dividing all of this divided by 8, right? So now I've got this rational expression of x plus 11 over 8. Well, I have to treat this like it's in parentheses. I have to treat it as a group. So I'm going to multiply in order to undo the division. That is going to be my first step. I need to undo the division first because I need to treat this like a group or like it has parentheses, so it must be my last. I have to save it for last. I'm going to do 8 times all of this, and I'm going to multiply this other side by 8 as well. Why would I multiply by 8? Well, because I'm dividing by 8. And if I have an 8 in the numerator, 8 in the denominator, or if I multiply by 8 and then divide by 8, that just creates a factor of 1, and I'm left with x plus 11. Negative 3 times 8, that's negative 24. Now, I just have one step left. I have x plus 11. I need x by itself. I just want 1x with nothing added to it. So let's create a 0 pair here, plus 11, now minus 11. And when I get the sum here, that's a 0 pair. X is equal to negative 35. Does it work? Well, negative 35 plus 11 is negative 24. Divided by 8 is negative 3. That's correct. That would work. Negative 35 would make this equation true. Alright guys, I hope this helps. I just thought you might need another video of some support on how we would go through and solve these equations. So keep working hard and we'll get there.